Good morning, class. Good morning, everyone. Good morning, everyone. Welcome back to the exciting session of chemistry today. And we are going to discuss a very, very important topic, and the name is de Broglie's theory. So let's begin that stuff straight away. The actual pronunciation of this de Broglie, it's not actually de Broglie, it's de Broglie. It's basically de Broglie. It's a good morning, everyone. Good morning. This is basically a French word, है ना? So it's pronounced as de Broglie, not de Broglie. Okay. Good morning, bachcho. Good morning, everyone. Settle down. Be quick. Settle down, everyone. Good morning, bachcho. Everyone. Good morning. So today we are going to discuss de Broglie's theory. The actual pronunciation is de Broglie. It's a French word. So let's begin that. Come over here. So till now, what we have seen that there is something called dual nature of light. Dual nature of light. And what do you mean by that? It means that light shows both particle as well as wave nature. So say if it has to show wave nature or say particle nature, then who will decide that light will behave as a wave or a particle? It is the experiment who will decide that the light will behave as a particle or a wave. Okay. So when you want to see light as a wave, you should do certain experiments like interference. Now this thing will be taught in detail in the physics, and second is diffraction. So when you do diffraction and interference, you will see that light behaves like a wave because these properties of interference and diffraction, they belong to the waves. Particles don't show interference and diffraction as such. Okay, but I mean, if you want to see the particle nature of light, it was proved by the 3 experiments in the beginning of 20th century, and these experiments were photoelectric effect. Second one, black body radiation, and third was line spectra, okay, of atoms. So when you are witnessing these 3 experiments, you will find particle nature of light. Here light will be existing in the form of photons, है ना? Photons, or you can say in the form of quanta. Or you can say over here, the light is quantized, it is discontinuous, but here light is continuous and exists in the form of wave. So this is the scenario in which we will be discussing the de Broglie. So when de Broglie came on the scene, he argued very correctly that light, which was traditionally assumed to be a wave, all of a sudden in the beginning of 20th century came to be regarded as particle as well. Now he said that universe is not partial. If it can allow a wave to behave like a particle, perhaps it is also possible for a particle like electron to behave like wave. He was simply saying that universe cannot be partial. It simply cannot say that wave, you can behave like a particle. I mean, by then light was existing as wave. We were having confirmed theory of electromagnetic wave theory given by Maxwell. He also gave 4 equations for that, mathematically correct equations, I mean, and they were able to explain all the phenomena existing by the end of 19th century. It was in the beginning of the 20th century, beginning with the black body radiation and photoelectric effect. I mean, there were certain doubts that whether the theory given by the Maxwell is completely correct or not, or there is something else which we can add on into it. So people said, the scientists said basically that light is wave as well as particle. So he said that maybe electron, which is particle, can also behave like wave. Now this conjecture is actually called wave-particle duality. Okay. Now this thing which I am discussing is existing in the microscopic world. Now this is significant in microscopic world only. That means the microscopic objects like electron, proton, neutron, alpha particle atoms, if they are existing as a particle and if they start moving, they will also behave like wave. So this was the argument given by the de Broglie, and scientists were actually stunned. Not exactly stunned, like they were like refuting what he is basically saying. Only Einstein was supporting him. So he needed some more mathematical calculations basically to prove his point. So he borrowed the two equations from the two very, very important personalities of the 20th century. One was obviously Einstein and other was Planck, the father of quantum mechanics as such. So from Einstein he borrowed that E is equal to mc square, and from Planck he borrowed that E is equal to hc upon lambda, which we have already seen. Now, since they both pertain to speed of light, that means this is the energy of light and energy of light. Since both are energy, we can equate them. So he equated these two equations with, like, say, mc square equal to hc upon lambda. C and C will cancel up, and this will be lambda equals to h upon mc. Lambda is equal to h upon mc. So this was a very significant equation, and he went on to do some more mathematical calculations and proved ultimately that this lambda is equal to h upon mc can be verified, can be proved for any particular velocity, any speed. Are you getting it? So he said this lambda is equal to h upon mv. Here he said it is like, say, c is the speed of light, but he also said that not only for light, it can be proved for any moving particle at any given speed. Okay, which particle? Any subatomic particle, any microscopic particle. Okay, so what's the significance of this thing? Before the existence of this equation, people believed that this pen is a particle form and it cannot be a wave. I mean, when de Broglie was trying to say that a ball can behave like a wave, I mean, it was like, say, what you're saying. We have never ever seen that, but that's the magic of quantum world. It simply defies your common sense. Whatever you see, whatever you give logic to, I mean, you give logic to on the basis of Newton physics, the physics given by Newton, and it does not pertain to subatomic world at all. Okay. So, what is the meaning of this thing? It means that any massive object moving with velocity v will always have a wavelength. That means any massive object, any ball, any pen, anything, if it moves, it will move in the form of wave. This lambda is the wavelength, and wavelength is of wave only. So this lambda is giving an indication that there is a wave, and this mass is belonging to the particle form. Only particles do have the mass, and waves don't have any mass. But he was saying that if a massive particle is moving with a speed v, will always have a wavelength. This wavelength, for example, earlier it was assumed that if I throw a ball, maybe it will follow this kind of a trajectory in Newton's world. But what de Broglie was arguing was that if you throw a ball, like say in subatomic world, that it will not move this way, it will move in the form of wave. And this wave is called actually matter wave. This is called matter wave. Are you getting it? What is that? When a matter moves, any matter, it can be electron, proton, anything will move in the form of wave. It will not move straight actually. Okay? But I mean, scientists at that time, they were only studying the macroscopic object, the big objects. So when we throw a ball, a car or truck, whatever, they move in a proper trajectory, this way. Are you getting it? So actually, what he was trying to say was that if a car is moving on a road, it will move straight. This was the statement given by the Newton. But he was saying that no, on the road, the car will also move in the form of wave. It will give you a wavy nature. But only difference is that this wavelength in the macroscopic world, in our world, in the big world, where we can see the things, touch the things, feel the things, this wavelength will be very, very insignificant, very, very small, say of the order of 10 to power of minus 36 meter. Now you cannot discern this. You cannot simply have an idea that what this is. This much of wavelength we are not able to see at all. But in the microscopic world, I mean, this is like say of 10 to power of minus, say maybe 9 meter, which is actually nothing but 1 nanometer. Now 1 nanometer is comparatively a significant figure. We can at least see that through the microscope kind of thing. Okay, come over here. So what I'm saying, he said that lambda is equal to h upon mv, which is also called h upon p, where p is the momentum. Achha, before I move forward, I mean, I want you guys to write down certain things that according to de Broglie, remember that electron can also behave like wave. It is a particle, no doubt, but it can also behave like wave. Secondly, that this wave will be called a matter wave. a matter wave. Whenever a matter will move, any matter will move in the form of wave. Now, this wavelength of this wave may be small, it may be large. It depends on the mass and the velocity also. Thirdly, he was saying that this electron, when moves in an atom, it behaves like standing wave. It behaves like standing wave. Very, very important. What do you mean by standing wave? What do you mean by standing wave? A wave which is not allowed to spread. For example, if I drop a stone in water, you will see that the ripples will keep on spreading inside the entire lake. And the wave is spreading. One more thing, for example, if I say something, the sound waves will keep on spreading. But over here, he was trying to say that electron is a standing wave, which means that if an electron is moving around the nucleus, it will move in the form of wave. And this wave is not allowed to spread. What he was saying that actually Bohr said an electron will revolve in a circle. He said that it will revolve, but not this way. It will move in the form of wave, because electron is going to show you the wave kind of nature. Yes or no? So, but this, if it is a second orbit, it will keep on revolving in the second orbit in the form of wave. But if an electron is in third orbit, it will not move definitely like this. It will move in the form of wave again. Are you getting it? But it will keep on moving in the third orbit itself. That is what I mean when I say a standing wave. The important thing is that electron behaves like a standing wave according to de Broglie. This is true or false? A stationary wave, yes, correct. Stationary wave or standing wave. I mean, if you are having an idea that according to Niels Bohr, all these orbits were called stationary energy orbits. So these waves which are moving in these stationary energy orbits are also called stationary waves or standing waves. I hope that is clear. Very good. Now come over here. Let's understand what is the meaning of this thing. From here I can say that lambda is inversely proportional to m. It is also inversely proportional to v. That means what? It means basically that lambda will be higher if the mass is lower, or the lambda will be higher if the velocity is lower. Are you getting that? So based on that, we'll do some questions. Let's do some questions now. Say the question number one, I'm saying that if I say that velocity of hydrogen molecule is equal to velocity of helium atom is equal to velocity of, not helium, let's say O2 molecule and CO2. The velocities are equal, the speed are equal. What I'm saying, who will have the maximum wavelength? Which molecule will have the maximum wavelength? Hydrogen, O2 or CO2? Come on, be quick. Everyone be quick. Hydrogen, because we know that lambda is inversely proportional to m. I mean that if mass is lower, lambda will be higher, and mass is lower for whom? Hydrogen. The molecular weight of hydrogen is least, so it will be H2, and lambda min will be, come on, who will show the minimum wavelength? If the molecules are moving, who will show the minimum wavelength? Come on. Very good, Vijay, very good. Come on. CO2, it will be CO2. Excellent answer, bachcho. Excellent answer. Achha, chalo, one more thing, let's do that. Let's do one more thing. So what I'm saying, next question is that if velocity of O2 upon velocity of hydrogen molecule is equal to 2:1, can you find out the lambda of O2 upon lambda of H2? Lambda of H2 upon lambda of O2. The ratio. Can you find it out? Come on. Can you find it out? Will it be 1:2, 2:1? What do you think? Come on. Be quick. Fastest fingers first. Okay, Blasi says 2:1, Vijay says 1:2, and some gamer is saying 32:1, 1:2, 1:2, 1:2. Okay, so most of them are saying 1:2 or 2:1, while the answer is actually 32:1. And see that, because I believe that you have missed the mass. The molecular weight of O2 and H2 are different, and you know that lambda is proportional to 1 by mv. Yes or no, beta? So over here, this will be like, say, m of O2 into v of O2 upon m of H2 into v of H2, speed of H2. So if I go by this thing, I believe this one is what? 32 is to 2. The molecular weights, and this is only 2 is to 1. This will cancel up. This will be 32 is to 1. Is that clear? So be careful while answering all these kind of questions. Please be extra careful. Hai spread the horizon. It's not 16 is to 1, but the molecular weight of O2 is 32. Okay, good one. Very good. Okay, so this being done, and like in this part they ask you some important questions on electron, proton, alpha particle, na? So please make sure that you are doing that as well. So let's do one question for that also. Okay, chalo, tell me, if velocity of electron is equal to velocity of proton, then find out lambda of electron upon lambda of proton. Come on, come on. Velocities are equal. That means it will be inversely proportional to what? Mass. It will be inversely proportional to mass. So can you do that? Come on. Ananya, 3, no proton, no way out. So I believe that it will be mass of proton upon mass of electron, because velocity will cancel out. Very good, bache. Very good. Saj is correct. Unknown gave her correct. Na? So mass of proton is what? 1837 times mass of electron, and this is mass of electron. This will cancel up. Answer will be 1837 upon 1. Good one. Very good. Vijay, very good. Gautami, very good. Very good. Keep it up. Keep it up. So the idea is that keep on having all these visuals in front of you. Keep on visualizing the question and you will be going through. Okay. So now come again. Let's do one more thing. I won't be deriving that stuff, but I'll be giving you direct formula. You will have to learn to apply that. Okay, so let's find out the relationship between wavelength and the kinetic energy of the given object. Okay, so let's say we know that lambda is equal to h upon mv. Okay, okay, now see that, can I say that first thing, if electron moves, then what will be? Then lambda of electron will be given by h upon square root of 2m kinetic energy. Are you getting it? And this will be, this is what? Mass of electron. This is mass of electron. Remember that? Or you can say h upon 2m ev. E is the charge of electron and v is the voltage. V is the voltage. Remember that? Voltage given in terms of what? Volts. Okay. M is the mass of electron, E is the charge on electron, okay? And when you will solve it by putting the values, you will get root of 150 upon V, V is the voltage, remember that again, this is also voltage, or you can say 12.25 upon root of V, V is the voltage, and you will get the answer in angstrom. This is when electron is moving, when electron moves, and this is the potential difference, or you can say simply the voltage applied. But what will happen if any other charged body moves? Second thing, second part, and this is equally important. If any other charged body of charge Q moves, in that case, you simply replace this charge E by charge Q. That's it. Nothing more than that. So lambda of that particle will be equal to h upon root of 2m qv, where q is the charge of the particle, m is the mass of the particle. This you will be using. This is a very important picture. Many people are not aware of this equation and they keep on doing the questions wrong. Okay. Achha, remember that whenever you are doing the questions, especially concerning this thing, kinetic energy, please make sure that your unit should be perfect. For example, weight or the mass should be in kg. It should be in kg. Lambda should be in meter. Any distance should be in meter. Speed or the v should be basically in meter per second. Are you getting that? And the kinetic energy should be expressed in terms of joules. So be careful regarding this stuff. Okay. Okay. Now, before I move forward, tell you one thing. De Broglie's wave theory or de Broglie's theory is significant in macroscopic world. True or false? Is significant in macroscopic world. True or false? Come on, T or F. Please write down quickly. It is false. Very good. False. It is significant only in the microscopic world. Microscopic world for very, very small particles. For the big particles like ball, truck, car, earth, The wavelength is very small, completely insignificant. And as you know that the chapter's name is atomic structure. So whatever we are dealing with a very small world, microscopic world, subatomic world. Okay, great. Chalo, aa jao. Okay, so here we go. Achha, before I do the questions on that stuff, I want to prove one more thing. So when de Broglie gave his suggestion that a particle can also behave like a wave in a microscopic world if it is moving, so scientists were like, what the hell you're saying? We don't understand anything at all. So he went on to do something more. Okay, this time he was having a competition with Niels Bohr. This was de Broglie. You know that according to Bohr, electron was a particle. Electron was a particle, and according to de Broglie, electron was a particle, could behave as wave as well. It was a particle, no doubt, but he was claiming that it can behave as a wave as well. And according to Niels Bohr, a nucleus is there, and electron revolves in a circular orbit. And when it revolves in circular orbit, one condition should be satisfied, and that condition is that MVR should be equal to NH upon 2 pi, where N is the orbit number. Okay. Now, when he gave this equation, he gave no proof. There was no proof given. So he was very much criticized for giving this equation without any proof. Scientists don't accept anything except for proof. Now, he was saying that electron, if it is moving in a circle, it will not move this way. It will move in the form of wave. He was suggesting this thing. Okay, now what I'm saying, boys and girls, let me know one thing, that suppose we are having a fixed wall, 2 walls are there, and I pluck a string out here, and I then click it or pluck it. I believe that it will move in the form of waves, and it will keep on vibrating in the form of waves. Yes or no? So these are called standing waves because they are not allowed to spread. They cannot cross the boundary of wall. Like this thing, suppose if I want to make a circle out of it, can I make a circle out of it? If I take a thread, can I make a circle out of it? Yes or no? So if I make a circle, this will become 2 pi r. Circumference, this will become 2 pi r. Yes or no? And I also know that this thing is called lambda. This thing is called lambda. This thing is also called lambda. Are you getting it? So in that case, 2 pi r will be equal to 2 lambda. But if I am able to make 3 waves, in that case 2 pi r will be equal to what? 3 lambda? Yes or no? Or 5 waves, 2 pi r equal to 5 lambda. Can I say that? So he was saying exactly same thing, that when electron is moving in a circle, in a wavy form, in the form of wave, in that case we can claim that 2 pi r will be equal to n lambda, to generalize that. And according to de Broglie, lambda was what? H upon mv. So we are replacing lambda with h by mv. 2 pi r equals to n h by mv. Yes or no? Now what I'm doing, I'm replacing mv and 2 pi here, interchanging their position. So when I'll interchange their position, what I'll get? I'll simply get mvr is equal to nh upon 2 pi. Are you getting that? What I'm saying is that with 2 mathematical lines, he was able to prove an equation which no one was able to prove, including Einstein. Are you getting it? This genius man of 21 years of age got Nobel Prize for proving this thing. Are you getting it? Now, according to de Broglie, what is this n? N is, according to de Broglie, this n is what, beta? It is number of waves. Okay? And according to Niels Bohr, this n is what? Orbit number. And the good news is that they both are same. That means orbit number is equal to number of waves. So a very, correct. So according to de Broglie, n is number of waves formed. According to Bohr, it is n is what? Orbit number. Since they both gave the same equation, one came by assuming electron as a particle, other gave or proved it by assuming electron to be a wave. Yes or no? So, I mean, if they ask you a question that in the third orbit, how many waves will be formed of electron? Answer is 3 waves. Orbit number is equal to number of waves. Chalo batao, in the fifth orbit, how many waves will be there? How many waves in the fifth orbit? It will be 5. Acha, suppose if they give you a question that electron is moving in an orbit and it forms 6 crests. It forms 6 crests. Tell me which orbit it is moving. Which orbit it is moving? It is forming 6 crests. So yes, correct. Very good. So 6 crest also means 6 troughs as well. 1 crest, 1 trough will form 1 wave. So there are overall 6 waves. So 6 waves means 6th orbit. Okay, good one. Very good. Okay, now let us fetch some more numericals from this part. When you will solve all that stuff, what you will get a very important thing, that lambda in a given orbit of electron is given as 3.32 into n by z. This will be coming in angstrom. Okay, this is the wavelength of electron, where n is the orbit number and z is the atomic number. So what I'm saying is that from here, can I say that lambda is proportional to n by z? Or which actually means that lambda will be higher if n is higher, and lambda will be higher if z is lower. Decrease the atomic number and wavelength will keep on increasing. Increase the orbit number and wavelength will keep on increasing. So one very important question they ask you is that wavelength of electron will be more in the first orbit or in the fifth orbit. Wavelength will be more of electron in which orbit? First or fifth orbit? Come on, be quick. Fifth orbit. We have seen that stuff. Right? So they can also ask you a question like that. Okay, one more question that if I talk about, say, first orbit, if I talk about the first orbit of, say, hydrogen atom, or maybe helium plus, or maybe lithium 2 plus, we are talking about the first orbit. N is equal to 1, 1 and 1. What I'm saying is that lambda will be more in which case? Of electron. Lambda of electron, I'm talking about lambda of electron will be more in which case? Hydrogen, because it is inversely proportional to Z. It will more in the case of hydrogen. So lambda of electron will be max in case of hydrogen atom. Yes or no? And it will be least minimum in case of what? Lithium 2 plus. Very good. So those kind of questions they will be asking you. So make sure that you are able to do the comparative analysis. They will rarely ask you absolute numericals as such, but they'll ask you definitely the comparative question, which is higher, which is greater. Okay, now come over here and one more question we will do. Okay, I'm doing this question, that which wavelength of electron, lambda means wavelength electron, exist in hydrogen atom. First one, I'm giving you 1.66 angstrom. Second, 3.32 angstrom. Third one, we can have 3.32, 4.98 angstrom, or I can have like say 6.64 angstrom. Which wavelength does exist in hydrogen atom? Come on. So I know that lambda of electron will be equal to 3.32 into n by z. So n by z, z will be 1. So if I put, acha, what is n? N is orbit number. Be careful. I want everyone to give the correct answer. Give your best shot. Come on, everyone. Be quick. Correct. So most of you have given the correct answer. The answer is 2 and 4. So when you will put n equal to 1, the minimum value of orbit is 1. So when you put 1, you will get 3.32. No doubt about it. The next value of orbit possible is what? 2. It is again 2 over here. Now 3.32 into 2 will be 6.64. Are you getting that? Yes, 2 and 4. Okay, I'm changing the question. Now instead of hydrogen atom, I'm making it helium plus. Come on. Which options are possible now with helium plus? I want everyone to give the correct answer. Come on, be quick. With helium plus. Okay, Zamir saying something, Sajid saying something. Okay, Lachanna, Vijay, Manish, unknown gamer. All. Very good, Amin. Like now everyone is giving the correct answer. Almost all. Very good, Bacho. Very good, very good. So I know that Z will be 2. Z will be 2. And if I put n value equal to 1, orbit number 1, it will be half of it. It will be 1.66. But when I'll put n equal to 2, 2 and 2 cancel. 3.32. That is the answer. If I put 3, Z is fixed now. N becomes 3. 4.98. N equal to 4, this will be 2 times 6.64. All of them are the possible answers. All of them are possible answers. Good, bachcho, अच्छा कर रहे हो. Keep on doing it. And I hope boys and girls, are you revising, students? Are you revising that? So before I move forward, I want to make sure that bachcho, that please keep on revising. Abhi, it is a good name, Abhi. What a beautiful name your parents have kept. Put it Abhi. Put it unknown gamer. I do not know. Okay, moreover, unknown gamer and medico doesn't make much sense, kind of thing. Okay, how will you feel that if someone says a doctor unknown gamer? It will be good. I mean, if you say Dr. Abhi, कितना अच्छा लग रहा है यार, है ना? Okay, चल, इधर आ जा. See, students, they will be giving you unit test. So for example, maybe in 15 days or 20 days, they will give you a unit test in which entire atomic structure will be coming. Entire atomic structure will be coming. Maybe some section of mole concept will also come. If you are not revising, this will all be gone. This is what major mistake the long-term people do out here, beta. They keep on focusing too much on the weekend test and they forget the long-term goal. That is basically revision of entire chapter. It won't take much better, but please try do it. Maybe in 1.5 months or so, they will give you entire atomic structure, entire mole concept will come in that unit test, and maybe they will give you little bit of thermodynamics. If you're not revising, they all will be gone. And now you ask me, sir, what I should do after 3 or 4 days? Sir, a unit test is there. No one can do it. You simply cannot do it. No one can do it. So please don't go for those kind of short-term goals. Go for long-term goals. Please keep on doing the revision and assume that after maybe 3 months, maybe they will ask you atomic structure, mole concept, thermodynamics, chemical equilibrium, and maybe ionic equilibrium. Suppose. So how can you do it in 2 or 3 or 4 days? It is not possible. And it's not about doing 1 or 2 times. It's about doing them multiple times. Become fluent into it. Become fluent into it. The fluency will give all kind of confidence. The speed will come. Now, maybe some of you are having a challenge. Sir, I am trying in the examination hall, but I am not able to do them quickly. The reason is lack of practice. Do practice it a lot. It's a national level examination, bachcho. Don't take it so lightly. Don't do the mistakes your seniors have done. Otherwise, you will be all kind of problem with it. Sir, when we have to use delta formula and En, देखो delta formula बच्चे, that will come बच्चे, but it will come slowly. But let me first clear the Kanti Srinivas problem. See, delta E is regarding difference in the energy of the 2 orbits, while this En is equal to E1 upon n square should be used to find out the energy of any other orbit. I mean, say this is the nth orbit, this is the first orbit. Then to find the energy of this orbit, you use this formula. To find the difference, difference should be this one. Kanti, is this clear? Now, Abhi, beta, I mean, to score 170 plus, you have to first make sure that what kind of blunders you are doing. You have to practice a lot. Practice a lot, have the conceptual clarity, practice more questions and again till you get the clarity. The clarity should settle down. Okay, now let's do some more questions now. What I'm saying, another question I'm saying, that if Okay. See, if I'm saying that in helium plus, the circumference of third orbit is given as x. You have to find out lambda of electron. Can you find out lambda of electron in the third orbit? If the circumference is given as x, I know that 2 pi r is equal to n lambda. 2 pi r equal to n lambda. 2 pi r is what? Circumference, which is given as x. So this is x equal to n lambda. What is n? Third orbit. This is third orbit. So 3 lambda. So lambda will be x by 3. Lambda will be x by 3. Very good, बच्चे रे क्या बात है? No. Abhi, no, don't do that. You will be in all kind of problem. Don't do that. These are like well-known questions, hai na? So that's why you are doing that. Listen to the question carefully. That's what you're doing, Abhi. You are getting lesser marks because of like you have preconceived things regarding certain questions. Examiner is clever. They can change the question immediately. So let's see that what I'm saying. But everyone knows that radius of the nth orbit in a hydrogen atom, radius of the nth orbit in hydrogen atom is equal to r1 into n square. Will you all agree or not? If I'm giving you the radius of the first orbit of hydrogen atom is x, in that case radius of the nth orbit will be what? X into n square. Yes or no? X into n square. Now what I'm saying, if in the hydrogen atom, R1 is given as X, for example, they are asking find lambda of electron in fourth orbit. So let's do it. Let's generalize it as well. So we all know that 2 pi r n is equal to n lambda. In the nth orbit, it will be having n lambda, and now 2 pi rn. Rn is what? X into n square into x into n square equal to n lambda. So n and n will cancel. This will be 2 pi x, or you can remove it. 2 pi, you can put an x. 2 pi x n is equal to lambda. Remember that. Who's giving the answer? No one giving the answer. No one giving the answer. Okay. So what I'm saying, if I go over here, now lambda is equal to 2 pi x into n. Now in the first orbit, who will give the answer? Lambda will be equal to what? 2 pi x into 1. Come on, in the third orbit, lambda will be equal to what? 2 pi x into 3. It will be 6 pi x. And in the fourth orbit, come on, lambda will be equal to what? 8 pi x. In the fifth orbit, come on, who will tell me? Lambda will be equal to 10 pi x. Is that clear to all of you? That's it. So this is general thing. Normally, now they don't ask you third orbit. They normally ask you fourth orbit, fifth orbit, seventh orbit. And the seventh orbit, how much? What will be the lambda electron in the seventh orbit? Come on, boys and girls, come on. Seventh orbit. 14 pi x. Very good. It will be 14 pi x. Very good. Excellent. Now, see, I'm giving you a question. It's like these are some very important questions. Be careful with that stuff. So, what I'm saying, we have got electron, we have got proton, and an alpha particle. Okay, and the kinetic energy of all these is given as, say, EE, EP, and E alpha, and all of them are accelerated. They are all accelerated by same potential difference. That means what? Voltage. That voltage is same. You have to arrange the kinetic energy in the decreasing order. How to do it? Now see that stuff. Okay, it is also given that lambda of electron is equal to lambda of proton is also equal to lambda of alpha particle. This is also given. If the lambda is same, in that case, lambda is equal to h upon 2m Wait. 2m kinetic energy. 2m kinetic energy. Okay? Or you can see that, I mean, let us leave that. Leave the voltage. We are simply saying that lambda of electron and lambda of proton, lambda of alpha is same. Don't go with that. Remove alpha from here. Right? So the formula with respect to kinetic energy and lambda is this one only. So lambda same, at same, 2 same. So can I say that kinetic energy into m will be constant? Will be constant, and if that is correct, I believe that kinetic energy is inversely proportional to m. Is inversely proportional to m? Yes or no? If that is the case, the mass of electron is less than the mass of proton is less than the mass of the alpha particle. If the mass of electron is less, kinetic energy will be most. That means EE will be more than EP is more than E alpha. Got it, everyone? Got me? Very good, beta. Farida, very good. Okay, good, very good. Gamer, very good. Good. Hussein, very good. Good, good. I hope everyone got it. Everyone got it or not? Good one. Chalo, एक question और करो. Do one more question. Do one more question now. What I'm saying, a proton and an alpha particle are accelerated through same potential difference. When I say same potential difference, that means what? Voltage V is same. Voltage is given as same. Can you find out lambda P upon lambda alpha? Lambda P upon lambda alpha. Come on, try it. It's a good question. Everyone should try it. Come on, everyone, be quick. Correct, Abhi. Very good. Correct. So, I mean, Acha, which formula we know whenever they give you potential difference? I only know one formula. What is that? Lambda is equal to H upon 2mqv. Okay, H is a constant, 2 is a constant, potential difference is constant. So over here, lambda is inversely proportional to m into q. Q is the charge on body and m is the mass of the body. So here I can say that this will be root of mass of alpha into charge of alpha upon mass of proton into charge of proton. Okay, now tell me, mass of alpha upon mass of proton is how much? What is the value of mass of alpha upon mass of proton? Come on. I believe that alpha particle is 4 times heavier. It is 4 times heavier. Will you agree or not? It is 4 times heavier. 4 times. देखो बेटा ऐसा होता है. See, alpha particle contains 2 protons and 2 neutrons, है ना? 2 protons and 2 neutrons, and the weight of proton and neutron is almost same. So can I say 2 proton plus 2 proton? That will be what? 4 proton. And 1 proton is what? A weight of 1 proton only. So if you take a ratio, it will be 4:1, for alpha particle. Come on over here. So this will be root of 4:1. Acha, what is charge of alpha upon charge of proton? I believe that alpha particle is helium 2 plus and proton is what? H plus. So the ratio of charge is 2:1. 2:1, this will be 2:1, and this answer will be root of 8:1, or you can say simply 2 root 2 upon 1. Will you agree, all of you? Good, very good. Very good. Chalo, come over here. Now let's do a question now. These two questions, coming questions, are very, very important, and make sure that we are not doing any blunder in it. Okay? कीबोर्ड में रूट लैम्डा और बाकी सिंबल्स नहीं है ना सर, बहुत डिफिकल्टी लग रहा है आंसर करने में. डोंट वरी एट ऑल. Don't worry at all. It's okay. The purpose is just try your level best with whatever resources you are having, and I'll understand that stuff. Okay, and I'll be more than happy if you are not able to give anyhow the answer in the classroom. It's okay, but please get the answers in the examination hall. So train yourself. Okay, be attentive in the class, try your level best, and practice hard in the evening, है ना? So that you can party hard later on when the results are down. Okay? Chalo, come. I'm giving you like lambda of photon. Lambda of photon is given as 6626 picometer. No, nanometer. We'll make it nanometer. Nanometer, है ना? And they are saying find momentum. Find momentum. Momentum of photon. Now you know that photon is nothing but a particle of light. It will travel the speed of light. Find the momentum. I mean, before this thing, we used to assume that photons are massless, है ना? But now we know that photons will be having some mass. And if they are having mass, they will have some momentum as well, because all photons will travel the speed of light. Find out the momentum. And be careful with the units. Be careful with the units, everyone. Come on, try it out. Come on, boys and girls, be quick. Crack it. (10 to power of minus 20 kg meter per second. Zamir Sheikh, very good. Very, very good. Good one. 10 to power of minus 28 kg meter per second. Very good, बच्चे, बहुत अच्छे. क्या बात है, शानदार. Excellent. Keep it up. So simple, बच्चे, so simple. Lambda is equal to h upon p. So p will be h upon lambda. H is 6.626, 10 to power of minus 34 joule second, and lambda, convert lambda into what? Meter, na? This will be 6626 into 10 to power of minus 9 meter, or I can say will be equal to 6.626, 10 to power of minus 6 meter. Can I say that? Can I say that? Very good, everyone. Very good. So 6.626 into 10 to power of minus 6. This will all cancel out, and this will be giving you 10 to power of minus 28. Since the unit of weight should be what? Kg. So m will be kg, and this p is what? M into v. So velocity will be meter per second. Meter per second. That will be the unit. Don't forget to give the units, and please see the units. They may sometimes give you option number A as 10 to power of minus 28 gram meter per second. It's not gram, it is kg. Okay, let's do one more question. Let's do the lambda of photon. Lambda of photon is given as what we can, boys and girls, come on, 6.6 angstrom. They're saying find mass of photon. Find mass of photon. Come on, solve it, and be quick with that stuff, everyone. Come on, find mass of photon. (3.3 10 to power of minus 33 kg. Okay. Be quick, everyone. Be very quick. Okay, let me solve it. So I know lambda is equal to h upon mv. I believe m will be Acha, since this velocity is the speed of light with photon, so this will be h upon lambda into c. Getting it? So h is 6.6 10 to power of minus 34 and lambda is 6.6 10 to power of minus 10 meter. Okay, don't forget to convert this into meter. So 6.6 10 to power of minus 8 into 3 into 10 to power of 8 meter per second. Speed is okay. This will cancel up. 10 to power minus 8. This is 10 meter. 10. 10 to power of minus 2 will be there. This will be 10 to power of minus 32 by, sorry, my mistake. 32. Can I say that m will be equal to 10 to power of minus 32 by 3. This can be written as 10 into 10 to power of minus 33 upon 3, which will be equal to 3.3 10 to power of minus 33 kg. Can we do it? Okay, we have got 1, 2, 3, 4. 4 people have given the answer and it's correct answer. Very good. Is it clear? Okay. Acha, can I ask you a good question? Just one last question of the day, and we'll be closing the class, and we'll be beginning the next class with Heisenberg uncertainty principle. Okay, so you, in the meanwhile, just prepare this stuff pretty well. Okay, now let me know one thing. Acha, which photon, violet or red? It's like, say, which photon, violet or red, will have more mass, or they will have equal mass? Violet or red, which one will have more mass, or they will have equal mass? Which photon? Okay, violet will have more mass. Some are saying violet. Okay, so violet. Everyone is saying violet. Everyone. समझ नहीं आ रहा है. आरती जी को क्या नहीं समझ में आ रहा है बच्चे? The question or what? Inversely proportional to mass. Very good. Aarti ji, what you are not able to understand? Let me know one thing. You are not able to understand this question? What the question I'm asking? I'm asking, there are photons. Red will have a photon, violet will have a photon. My question is that which photon will be heavier? Which will have more mass? Dekho, we all know, we have just done the previous question we have done. Lambda is equal to h upon mc. H and C are same. All will move with the same speed. All of them will move with the same speed, and in that case m is inversely proportional to what? Lambda, which actually means mass will be more if lambda is less. And we all know, as we move from left to right, the lambda increases. So for violet, lambda is less, but for red, the lambda is more, which this is all we have learned earlier. Yes or no? So if lambda is less, mass will be more. So over here, mass will be more. Here, mass will be less. Are you getting it? Everyone? Sir, what is the syllabus for this weekend? But I do not know, but I'll let you know in 1 or 2 days. Give me some time. Till then, you keep on preparing. Again, Vijay, I'll say that please do not worry too much about this weekend game. Worry about the revision, more revision. Whatever is going to come will come anyhow, in the weekend. But if you are able to revise the previous one, you will be champ. Trust me. Don't commit the same mistake. I mean, this same question has been killing many people every year out here. They worry so much about the weekend test. They are so much concerned about the weekend test that they forget the long-term goal. Revision karo. Do the revision, a lot of revision. A lot of practice, multiple times. How many times I do not know, it depends on you people till you start getting good marks. How many good marks? It's up to you also. For me 120 is okay. For me 150 is good. For me 170 is good. So you will decide. Okay? Vijay ji, getting it or not? Understand or not? बोल ही नहीं रहे. In the next class, we'll begin with Heisenberg uncertainty principle. It is not a lengthy topic, so we'll be covering it up, and then we'll be moving into quantum mechanics or the quantum numbers. Okay. So this atomic structure is like for maybe hardly for 3 or 4 lectures maximum, and after that we'll begin the mole concept. Are you getting it? So before we move into mole, you should revise this chapter as many times as possible. Okay, become the champion of this thing. So I wish you all the best. God bless you all. Bye bye. Bye bye.